today's lesson, we're going to learn how to deal with zero and negative exponents. For the do now, for the first part of it, you've got 3x squared y cubed to the third power. So basically, you want to do 3 cubed, which is 27, x squared to the third power, which is x to the sixth, y cubed to the third power, which is y to the ninth. So that's being multiplied by 2xyz. Don't forget how to multiply numbers. 27 times 2 just becomes 54. You total out all your x's for x to the 7th. You total out all your y's for y to the 10th, and then you're left over with a z. So that should be a refresher from yesterday. Now, anything to the 0 power is always 1. We talked about why that is in class, so we can do that again if you need some extra help with that. Anything with the negative exponent can be rewritten so that it's positive by moving the base from the numerator to the denominator or vice versa. By moving the base from numerator back and forth to denominator. Back and forth to the denominator. Okay? So when you deal with fractions that have exponents in there, the first thing you want to make sure that you do is that you distribute exponents outside the parentheses to all the terms inside the parentheses. You want to make sure that you combine same bases that are in the numerator or denominator. And then for the third thing, and I'm going to call this flip out, and I'll explain that more when we actually do problems. You're going to flip out bases with negative exponents so that they become positive. And then if the same base is in the top and the bottom, numerator and denominator, you're basically going to do the question of where are there more, how many, top or bottom, or where are there more, top or bottom, how many more, sorry. And with that, you're going to be doing some sort of subtraction. And you subtract the exponents and leave the base where the larger exponent is. So if these words are a little bit confusing right now, when we start doing the examples, I think you're going to be just fine. 1a, anything to the 0 power is just 1. So this answer is just 1, and you're finished. B, here's where you have a negative exponent. Here's where I'm talking about the flip out piece. So as a fraction right now, I've got 3 to the negative 2 over a 1. The fact that I've got a negative exponent attached to my base of 3, in order to make it positive, I need to flip it from the numerator to the denominator. And once you flip it, once you send it down below, you're going to out the negative. So I flipped 3 from top to bottom, and then I outed the negative exponent. And now with nothing left in the numerator, you need to make sure that you have a 1 up there. So this answer really simplifies to 1/9. 2a, make it a fraction, put it over a 1. Circle any negative exponent and its base. All that's circled is b to the negative 3. So what doesn't move is the a that was never circled. What does move is the b. It flips to the bottom and you out the negative exponent. Your final answer should be a over b cubed. 2b doesn't have any negative exponents. Here's just where you ask yourself the question, where are there more of these variables, top or bottom, and how many? It's where the subtraction is being used. In terms of the x's, they're more on the bottom, and they're more on the bottom by 2. In terms of the y's, they're also more on the bottom by 2. And you can't have a fraction without a numerator, so 1 goes up there. (3a), anything to the power of 0 is 1. All of this parentheses raised to the 0 power. Answer, there you go, it's just 1. On the next one, you need to remember that the negative 5 has to get distributed to both the top and the bottom. Also understand that the exponent right now is a negative 1 to the 1 and a 2 to the 1. So what's going to happen is you're going to get negative 1 to the power of negative 5 over 2 to the power of negative 5. Anything that has a negative exponent has to flip. It's a -1, I get it. The -1 shouldn't bother you, but the fact that you've got a parentheses attached to a negative exponent, we got to flip out that guy, and we got to flip out that guy. So what ends up happening here is on the top, you get a 2, and now the exponent becomes positive 2 to the 5th. On the bottom, you get a -1, but the exponent becomes positive. You flip out the negative exponent, not the negative number. And then what happens here is 2 times itself 5 times is just 32. -1 times itself 5 times is just -1. And this final answer becomes -32. On 4a, if you look at anything that has negative exponents attached and you circle them, on the top I've got this, y to the -1, and then on the bottom I've got z to the -3. So what's not circled doesn't move. The numerator keeps x is 2, z to the 4th. The denominator keeps x, y to the 4th. What moves up top is that z, and it becomes z positive 3. What moves down is that y -1, and it becomes y positive 1. When you start simplifying the top and the bottom, on the top you've got x squared with z to the 7th. On the bottom you have x to the 1st with y to the 5th. And then you ask yourself the question again, where are there more x's, top or bottom? On the top, how many more? To a power of 1. Where are there more z's, top or bottom? They're more on top. That's where all of them are actually, z to the 7th. And y to the 5th are only found on the bottom, and they have to stay there. There's your final answer, x z7 over y5. On 4b, again, just worry about the negative exponents. X to the -2, z to the -3. I'm going to color code this one, x to the -5, y to the -2. What doesn't move is what wasn't circled. In the numerator, 12y7 over 4z2. No negative exponents there. What goes up top that flips up there and outs the negative exponent, x to the 5, y to the -2 goes up top, out the negative exponent. X to the -2 from the top flips out to the bottom, you lose your negative exponent. And z -3 up top moves down, you flip out the negative exponent. If you tighten this up on the top, you're going to get 12 y9 x5. On the bottom, you're going to get 4 z5 x2. Well, now we need to simplify. 12 divided by 4 is just 3 over 1. The 1 is not necessary. There are more y's on top. That's where all of them are by 9. There are more x's on top by 3. And the only z's that are found are on the bottom, and there's 5 of them. And there's your final answer, 3y9 x3 over z5. A few more to go. 5a. What's happening up top is you need to make sure that you distribute your outside exponent to everything inside, which means 2 cubed is 8. X to the -2 cubed is x to the -6. Y to the 4th cubed is y to the 12th. On the bottom, it's just exactly what's there. And now you go back to the old stuff. Circle the things that have negative exponents. That's all that moves. 8y12 doesn't go anywhere. x5 doesn't go anywhere. The x -6 flips to the bottom, out the negative exponent. Y -2 up top. What this leaves you with now is 8 more y's. Actually, the only y's are on top, and you total those out for 14, and you total out the x's on the bottom for 11. So there's your final answer, 8y14 over x11. On the last one, again, distribute in that negative exponent to everything. So it becomes 3 to the -2. And then it becomes a to the -4. And then it becomes b to the +8. Remember, power to a power, you multiply. On the bottom, it becomes 2 to the negative 2, a to the positive 6, and b to the negative 12. All that moves are things that have negative exponents. So what's happening here is I've got my b to the 8th on the top. I've got my a to the 6th on the bottom. What jumps up is 2 squared and b to the 12th. What jumps down is 3 squared and a to the 4th. Let me just get some more room here. What's going to happen now is on the top, I really have 2 times 2, which is 4, and then b's total out to 20. And on the bottom, I've got 3 times 3, which is 9, and a's total out to 10. Nothing left to do. The last two are multiple choice. This one, what's it equivalent to? And again, you ask yourself the question. There's more x's in the bottom by 2. So I need to have x in the bottom by 2. And not there, not there, not there. Well, there we go. And let's see if that makes sense. So 5 divided by nothing, or 5 divided by 1, I should say, is 5. More x's on the bottom by 2, more y's on top by 1, and that's exactly what we wanted. Now this one definitely is a little bit more tricky. Here you still distribute the power in. So when I distribute in my cubed power, this now up top becomes b to the 6n plus 3. On the bottom, because I've got bases that are the same, I can add the exponents, which means I have to combine like terms. That's b, and now I actually have n plus 4n plus 3, or 5n plus 3. So the question is, well, where do we have more of the b's? There's 6n plus 3 on the top. There's 5n plus 3 on the bottom. If we do the subtraction, what's happening is this. You're taking the b, you're taking 6n plus 3, and you're going to subtract 5n plus 3. And what ends up happening now, it's kind of like you distribute the negative 1 in. So you really have b, get some more room, and it's going to be 6n plus 3 minus 5n minus 3. Well, these guys cancel out. 6n take away 5n is just 1n. And there's your final answer. So b to the n, choice 3. And that's it. All right, you should be good for the homework.